Yeah, I would like to record this meeting. And here are the examples for our naming conversion. I have detailedly given the examples. Yesterday, we have started discussing some basic or primitive data types, which we have only discussed about int, float, complex, string, and Boolean types. And here are some other data types in Python. And they are also having some names. Let me say the text type or the character type. The data type is str, that is string, and numeric types are integer, floating point value, and complex value. Sequence types are lists, tuples, and range. Following data types will be discussed later. Just remember the names list, tuple, and range. Following are the data types we are having in Python. And the mapping data type is a dictionary. And sets, we have a normal set as well as a frozen set. And Boolean type, we are having bool, and binary types byte, byte array, memory view. And we have also discussed about the type of a variable. We have seen some example for integer type, floating type, complex type, and string type, as well as the Boolean type. And we have also discussed about the ID, and this ID returns as the memory location of a assigned variable. And we have also discussed the topic called as memory pooling. And I also started operators in Python. What are operators? Operators are the special symbols in Python that carry some arithmetic or logical computations. The value of that operator operates on a operand. Yesterday I have told you, right? The operation is being done on some operands with using some special characters called as operators, such operators. And these operators are divided into few types, and they are arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. I hope I am clear. Yesterday we have finished till this. I think I have also discussed the arithmetic operators. Let us just see from arithmetic operators again. So some basic arithmetic operators are addition, subtraction, multiplication, division, modulus, exponential, and floor division. And here we are having the examples for each type: subtraction, multiplication, and here I am using a normal division as well as a, what do we call it, floor division. Yes. And I have also told you the differences between the normal division as well as the floor division. Hope you remember it, or I'll just recall it. When we are doing a normal division, whenever we get some output, it will be in the floating point value. The data type of the variable will be a floating point data type variable. So if we only want the integer part of the variable, that means we do not want any decimal points after the integer, then we need to use the floor division. That is this double division symbols. We are going to get a integer value without any decimal value. And here we have seen the examples, and we have also seen the power. Double asterisk is used to give us the output for power. And this is all about the arithmetic operators. Let me start with the assignment operators. So we haven't discussed assignment operators in detail yesterday. I have just told you about the equality symbol. So assignment operators are used in Python to assign some values to the variables. For example, if I'm going to assign a value 5 to a variable called a, then we are going to use a operator which we call it as equal to. Equal to is the assignment operator. Here just it is given as an example. And I have also discussed the notation for shorthand assignment. Here I have clearly mentioned that if you are going to add if you are going to add two variables like a and b, you can simply use plus equal, so that it means a is equal to a plus b. Similarly, a minus equal to b, a is equal to a minus b, and so on. Whatever the operators you are having, you can use this shorthand assignment. Here just I have inserted few examples. This is the shorthand assignment. We are just assigning a value to our variable. Whatever the value it is, it can be an integer value or a complex value or a Boolean value or a decimal value. That means floating point value. This is all about the assignment operator. Assignment operator is equal to symbol, equal in addition to some other operator. If you add the equal with some addition to other operator like plus, minus or multiplication or any other operator, then the following notation we call it as shorthand assignment. And next, let us discuss about comparison operator. Here, as it is becoming some delay to type each and everything, or it's taking time, I have already created this file. I'm giving you it in the form of notes as well as with the examples. So, what are comparison operators? Comparison operators are used to compare values between the variables. For example, if you are having a value called 3 and another value 5. If I'm going to compare this value, let me say 3 is greater than 5. I'm comparing the value 3 with 5. So we are obvious that the following statement is false. So whatever the output it returned is false. Okay. Next, I'll be showing few other examples. Let us try in this fashion. I'm going to say 3 is less than 5 and the output is true. So let me say all the comparison operators to you. First one is the greater than operator. The operation of this greater than operator is to compare the left side value. If the left side value is greater than the right side value, then it returns a value called as true. And the less than operator, if the left hand operator of the left hand variable is less than the right hand one, then it is going to give us true, or it is going to return us true, as I have shown in the below examples. And we are having equal to operator. When we use double equal symbols, it is going to compare. When we are using just a single equal to symbol, it is going to store some value in a variable called a. And if I'm going to use this double equal, then we are going to compare few values. I'll be showing with it some examples, don't worry. And we are having not equal to symbol. This is the notation for not and equal, not equal. And this is the notation for greater than or equal to and less than or equal to. You can just read them. You'll be understanding them clearly. So just let us see another example. Let me assign some h is equal to 100. It is showing me a warning that I have connected to GPU, but I am not utilizing it. As I am not dealing with some any major projects, I am not using the GPU. So let us just set that runtime to none. And it will be connecting to the Google server again. Okay, initializing. It's connected. H is equal to some value 100 and G is equal to 100. Now let me see what I am going to get if I use in this fashion. H is equal to Z. So it has returned a value called as true. So here we are comparing the value H and G. It is returning as true as both the values are equal. And in the other sense, both the variables are stored at a same memory location. So it is saying us that the following value is true. If I use the following notation, then I am going to get as false because H and G are allocated in a different memory locations, as well as they are having some different values. So this is the value I have got. Let me again keep it for your reference. Okay, H equal to G. We are going to get it as true. Again, I am going to add a new code cell. Okay. Now what is the next operator? We are having not equal, greater than or equal, less than or equal. Let me say Now we have just seen with the integer data types, right? Let us see some other thing. String A is not equal to string B. So it returned me true. What does it mean? The following A is not equal to B. Yeah, the condition is true. So it has returned me true. Let me check with the same thing. A not equal to A. The following condition is false. So it has returned a statement called as false. The output we have got is false. So,
Sir,
okay.
hello, sir. I have a doubt.
Yes, please.
So you have told that it's string A, but it's a single alphabet. That means it's called as variable.
See, here I am
We,
mentioning in the quotations, right?
yes, sir. I understand.
Okay,
But it
fine.
should be normally we should mention in single quotations now.
So it's not at all a problem. You can mention it in the single quotations too. We are going to get the same output. Let me show it to you. Is it okay?
Yes. Sir.
We can either use single quotations or double quotations to form a string.
Okay, means a single alphabet can form a string, no?
Yes, a single alphabet is also a string. Let me say
As well as
apple, apple, and let us see the output. Still, it is applicable. It is comparing the string also. We have got it the output as false. Is it fine?
okay, sir. Yes, sir.
Okay. Now we are having two more operators. Let's see examples for those two also. Greater than or equal to, right? Again, we can use this same thing. Greater than or equal to, you just see, well, however this condition is manipulated. Greater than or equal to G. Can you expect the output? Can someone expect the output? Okay, let us see. Yeah, true. Because the same value is being assigned. So we have got true. In this case, we are going to get false because the value of G is greater than the value of H. And if I'm going to give 99 for G and execute it, I'm going to get it as true. It means the following condition has been satisfied and we have got an output as true. So the point to be remembered is whenever we are using a comparison operator, whatever the value we are returning or whatever the output we are getting will be either only in two forms, that binary forms. Either it will be a 0, which means false, or 1, which means true. We are going to get only two outputs, true and false, when we are using comparison operators. Please make a note of it. I have not mentioned that. And next, let us dive into logical operators. So, are you people aware of these logical operators? In any of your subjects? Like, may I know to which
Yes,
branch
sir.
you belongs to?
EC.
ECE. And the other?
I am from Triple.
Okay, fine. So, hopefully, you have seen it in DEC, right? Digital Electronics.
DLD.
Yes, sir.
Logical
Yes, sir.
operators.
Okay, DLD. What are the subject? It's the digital circuit subject. Okay, I hope you are well aware of this operations of and or and not, right? You'll be having
Yes,
gates.
sir.
Yes. The following operators are same. There will not be any modification in that. Whenever we are going to use this and or not operators, whatever we get the output in our logical gates, we are going to get the similar output here. So we are having three logical operators and or not operators. So when the and operators gives us true, when the given operators, when the given both operators are having same value, yes or no? True if both
Yes, sir.
operators are true. Let me don't say that same, but if both the operators are true, sorry, if both the operands are true or both the conditions are true, then we are going to get true when we use and operator. So if one of the conditions from X or Y is true, then we are going to get true if we are using the OR operator, or logical operator. And NOT operation, it is the complement of a given statement or the operation. Here I have given some examples. Yes, A is equal to 0, B is equal to 1. What I am doing is A and B. Here A is false as it is denoting 0 value, and B is true as it is denoting 1 value. So whenever we are performing an operation between A and B, we are going to get a result in the form of digits. In this case, as we are using the numbers, we are having our output as digit, which means 0 means false. And if I get 1, then it is true. Let me show with OR operation. A or B. I have got here 1, which means whenever we are performing a OR operation between A and B, as one of the variable is true and the other is false, we are getting true for both the, true for the OR statement and false for the AND operator. And if I am going to use NOT operator, let me see how it works. I'll show with this example. Here I am assigning a X value with true and Y value with false. So when I am going to print X and Y, it is returning me false as not both are true. And when I am using OR operator, it is going to return me true as one of the operator or the one of the statement is true. We are going to get it true. And if I am going to use the NOT operator, NOT X is false. NOT X means as we have assigned X as true, what will be the NOT X? It will be false. Let us just see here. Print NOT of A. What is the expected output? True. As we have assigned 0 to the A and it is giving the complement of our output, it is returned a value called as true. And please remember that we need not to mention any quotations while we are assigning either Boolean operations to a variable. We need to just use the following notation. The first letter of this true will T will be capital, as well as the first letter of false will be capital, and the other variable which we are having is none with the capital letter as its first character. This is an example for the logical operators. And coming to the bitwise operators, hope you are also aware of this bitwise operators. However, let me discuss them. Bitwise operators acts on operands as if they were strings or binary digits. The bitwise operators can be used for both strings as well as binary digits. Hence, the name has been called as bitwise since the operation is done by bit. So here is an example. Whenever I am going to represent 2 in the binary format, it will be in this format 1, 0. And if I am going to 7 in the binary format, 111 represents 7 in binary format. So to perform some operations, here I have taken an example so that you will understand the operator itself. So here we have seen logical operators which are and or not, and here also we are having the same and, but it is a bitwise and. So what it does is it compares each bit by bit and gives us the result. So and is a bitwise operator. Or, this is the or symbol. It is a bitwise or operator. It is a bitwise not operator, negation. And it is bitwise XOR operation. It performs our XOR gate operation. And it is a bitwise right shift as well as left shift. So here I have an example like 10. It is represented in the binary format as 1010 and Y as 0100 in the binary format. When we are going to use a bitwise AND operator between X and Y, 10 and 4, then it results us in this format. Since do you want me to show that? Okay. We are having 4 value as We are having 4 zeros, 0, 1, 00, and 10 value as 0, 0, 0, 0, and what is it? 1, 0, 1, 0. See here, if we observe, when we are performing AND operation, let us come from this side. So whenever we perform an AND operation between bitwise operator 0, 0, we are going to get it as 0, and 0, 1, it will be 0 again, and 1, 0, 0 again, and 1, 0, 0 again. So the corresponding output what we get is all zeros. The output will be 0. Let us just try with that. X is equal to some 4, y is equal to some 10, and we are expecting x and y. Let us see the output. So whatever the output we have got is 0. So it is performing a bitwise operation. So we have resulted the output as 0. Whenever we perform OR operation, sorry, this is used to perform the OR operation, the following operator. So it has resulted as 14, right? You do the OR operation between these two and these two operators in the form of a bitwise fashion. So in first position, it is having both zeros, so it will be 0. In second position, we are having 1, so we'll be having 1. And third position, again it is 1. And fourth position, again it is 1. So it has resulted in the value of 14. It has resulted 14 because it will have a binary conversion like 1110. 2 plus 4, 6, 6 plus 8, 14. This is the output. Similarly, when we perform bitwise NOT operation, we are going to get the following value. Here we are going to perform bitwise NOT operator on a single operand, not on multiple operands. As we are just negotiating the value, we will be getting in this fashion. See, whatever we are having zeros, zeros will be converted to ones, as ones will be converted to zeros. Let us see that example. Not of x, and I'll get the output as -5. Here it is showing -11. Okay, maybe it has just taken up to these digits, is it? Or is our x value changing? Let me just print x. So x is 4, right? Okay, 4, and all the other things are converted, and it is giving us a output as -5. Sorry, I didn't absent it. Yeah, -5. And similarly with the XOR operation, the each bitwise operators are performed on this given operands. The operand is performing a bitwise XOR operation, and it results in a output. Similarly, the bitwise right shift as well as the left shift. So let us just see the examples for bitwise right shift as well as left shift. In this bitwise right shift, when I am going to create a variable and assigning it a value 10, it means we are having in the following format 1010. When I am doing a bitwise operation for 2 times, here the value 2 indicates shift the bits 2 sides to right side, as it is a right shift. Okay, it is a right shift 1010. When we perform right shift operation, what happens is the following 2 bits, whichever the following 2 bits are moved to the right side, and it results in following fashion. So we are getting an output called as true. See the output? It will result in an output called as true. So whenever we are performing a left shift operation, whenever we are performing left shift operation, the following variables moves to the left side. As I have mentioned twice, they will be moving twice and they result in some value. Let us just check it. 0 0 1 0 space 1 0 0 0, right? So the following value is having a value of 40. So it has resulted in a value called 40. So let us try to do right shift for thrice. So it should result with a value of 1. As this 1 is also shifted here, it is resulting us with 1. And if I perform the operation once again, it will result us in a value 0. So we have just performed it twice. We are resulting with a value called as true. And we have completed arithmetic operators, assignment operators, comparison operators, logical operators, as well as bitwise operators. You people need to practice on this so that you will be remembering. Okay. And there are two types of special operators in Python. Let us discuss those special operators also. So Python is it is offering some special operators called as identity operators as well as membership operators. Let us see what are identity operators. Identity operators, there are two identity operators. One is and the other one is not. So what is the objective of this is? The following is operator returns true if operands are identical. So let me say in this fashion. We have assigned some value x1 with 5 as well as y1 with 5, and if we try to, they have not given example with x1. Let us do it. Okay, what I am going to do is x1 is y1, so it should result as true because both x and y are having identical values or they are referring to the same object. It has returned as true. And is not operator returns true if the operands are not identical as shown in the example here. Here x1 is not y. This statement is false because x1 and y1 are having same values, are referring to the same object. So it should return true if you use is. As we are saying is not, it is returning us the value called as false. And the following what are these? Identity operators can be performed on strings, integers, and the following format we call it as list or arrays. If you are aware of, this is the list format. It can be applicable in this list format also. Whenever I am saying x2 is y2, so x2 and y2 both are assigned with the hello string value. It is returning with a true value. So both the list are having same values, but whenever we use x3 is y3, the following returns false statement because both this list does not refer to the same object. So they are not identical or they are not stored at a same memory location. It will return us in a false statement. Please make a note of it. Is and not is operators perform quite well on lists, our basic primitive data types, which includes integer value, floating point value, strings, and etc. This is all about our identity operators. Is and is not our identity operators. And next we are having membership operators. In and not in are our membership operators in Python. So the operation of these two operators is in. It will return true if some variable or value is found in the sequence. Let us see with an example. Here I have assigned a value x to hello world. So if I'm going to print h in x, as this character h is present in the string hello world, it will return us output as true. Okay, so not in operators result as true if a variable or value is not found in the sequence. So as I have already told, Python is a case sensitive language. We are using hello having h capital, but here we are using hello H with small letter, and trying to find that character or the string in the given sequence. As the following string is not present in the given sequence, it is returning as true. Here, if we just use hello in X, it will return as false. But as we are using hello not in X, it will result us in true value. Okay. And 1 in Y. Y is having 1. The following format is dictionary. We'll be discussing it later. Don't worry. We are trying to find if 1 is present in Y. Okay. As Y, this is the key value. This is a key. And this is a value. And if we refer to it as 1 is present in our dictionary, it is returning true. And if I find for A in the given string Y, it does not point to this value in the dictionaries. So it returns false. Here you might get a doubt like the following character A is present in the dictionary. But when I am using membership operator in, it is returning me false. It means that whenever we are working on with dictionaries, we can only use this membership operators for the key pairs. We call it as key value pairs. So whenever only for keys, we can use this membership operator, the in and not in our membership operators. This is all about the membership operator. And next, let us see Python output using print function. In all the examples, I have used this print function. Already you might have known the usage of this print function. The usage of this print function is to print some particular value or the statement which we have inserted in this parenthesis. For example, I am going to write a sentence. This sentence is outside the screen. What it is saying here, it is a statement. It is included in the parenthesis of this print statement or this print function. So it will result us with the following output. What will be the output? The sentence is output to the screen. And it can also refer to a value. It is the another format to print some value. So this is something new to you. See here I am using print. In the parenthesis, I am writing the value of A is the following statement I have written in quotations, and with a comma, I'm giving a value called as A here. Here I'm not giving 5. I'm just giving its operand called A. So whenever I execute it, I'll get the statement like the value of A is 5. Let us see. Will it work? See, it has worked, right? I'm assigning a value to 5. So whenever I'm interested to print the following value of A, let me say it is having some unknown value and I'm going to print it. We are not sure that it is 5. Let us think we don't know that A is assigned to 5, but we want to print the value of A. So we can print in this fashion. If you want to print a variable, you can just, if you are interested to print only the variable without any statement, just use the following format: print of A. We need not to write it in the quotations. If you follow the quotation notation, the following output gives us the statement which is in the quotations. So we should be clear with this. We should not use quotations if we are interested to print some operand value. If you are interested to print the statement or the value, whatever we are typing here, then we should use them in the quotations so that we will be getting the exact value in our output screen. The value of 5 is, the following statement is written in the quotation. You can use either single quotation or a double quotation. So it will give an error. Double quotation, it will give the same output. There will not be any difference. The value of A is 5. So far we